maintenance needs to have a really integral role in this tool. And so the more it looks like their day-to-day hot and cold call, the better it is, right? So if we can make that push of that FDD resolution look like a work order, then it's much easier for the organization to adopt it. And I really believe that was integral to our success.
Hey friends, did you know the best way to continue learning beyond the Nexus podcast is to sign up for our newsletter? The Nexus newsletter is your one-stop shop for staying up to date on the latest smart building trends. Sign up today free of charge and we'll drop this industry-leading resource right into your inbox every Wednesday. If you're already signed up, double high five and thank you, but now tell your coworkers and your friends. Once you're signed up, the best way to continue the learning is to join the Nexus Pro membership community or our online course offering headlined by our flagship course, Nexus Foundations. Diving into these products allows you to connect with our global community of like-minded changemakers. Links are below in the show notes, and now, on to the pod. All right, welcome to the Nexus podcast. This is the first episode in a new series diving into case studies of real-life larger scale deployments of smart building technologies. I'm so excited about this. I emphasize the word real life because we're not really here to create some sort of marketing fluff story here. We're here to share real lessons from leaders that have put smart building technology into their building programs. I also emphasize large scale because we're not here to talk about pilot projects. We're here to talk about deeper commitments to integrating technology into operations and sort of actually changing the way buildings are operated. So today we have a story coming out of the University of Iowa on their journey integrating fault detection and diagnostics, or FDD from here on out in this conversation, into their maintenance operations. And so, Tom, we're going to start with you. Can you introduce yourself and talk about your role on the team?
Tom Moore, Senior Manager of Operations and Maintenance for the University of Iowa. My teams cover all of our general education funded buildings on campus. That's basically classrooms and research and no sports, no hospital, none of that kind of stuff. The reason I'm on this team is it's very important for my team as a maintenance group to be able to go out and solve these problems efficiently and quickly, instead of just tickets coming out from heaven and no one knowing where they're coming from. So that's why I'm mainly involved, is because as the end user, the group that's going to have to fix these problems, we wanted to make sure we're a part of the process.
Absolutely. And why would you say, from the university standpoint, why do you guys use FDD? So what are the outcomes you're hoping to get from this technology?
FDD is a tool for our group. We have a group called the R group, the Analytic Resource Group. They're a little bit bigger than FDD, well, actually a lot bigger than FDD. They're kind of our retro commissioning group, but they use FDD tool as a tool to, find which buildings we need to go to and take the best look at it, along with deciding the day-to-day what needs to be fixed, just without all this retro commissioning blitz stuff that we do. So we do blitz with this group. It's basically, we take this whole group, all the mechanics that work on the building, upper management and everybody, and we go to this building and we say, we're going to bring this building back up to snuff. We're going to generate projects out of it, all that good stuff. So that's what's great about the FDD programming. A lot of that reporting stuff we already know. A lot of the root causes we can figure out pretty easy with what the tool does. We started out with wanting to see all this energy savings, and we did see considerable energy savings. But now that we're probably 5 years in, we're definitely switching to concentrating on a maintenance program as opposed with an energy benefit, as opposed to an energy program with a maintenance benefit.
Cool. Very cool. And from the maintenance side of things, I think a lot of listeners will be familiar with the benefits of energy savings. Obviously, we don't need to dig into that. What are you looking for from a maintenance perspective? Like what is it? What does success look like from a maintenance perspective?
Finding that needle in the haystack just takes you right to the needle, and you don't have to worry about all the hay around it.
Got it. Yeah. So getting, for the same amount of time you're looking for issues, the software can help you get there faster.
It also helps our new technicians with training. They actually get to see what a seasoned tech would look at on our faults. So they're not just starting from scratch either. They probably wouldn't have never been able to diagnose this problem without all the help that this tool provides.
Totally. And just to set the context for the rest of this discussion, I'd love to just sort of rattle off a couple questions, rapid fire round for you before we get into the details here. Who's the software vendor that you guys are using today?
We use Clockworks through our Schneider partner, the BasePoint Group.
Cool. And how many buildings is the software installed in?
47 currently. We've had up to 54, I think, at one time. I think about 10 buildings we decided we weren't seeing the benefit. So we reduced and then added a few, but 47 is what we're currently staying at.
And what's the total square footage?
6,880,000.
And when did the project start?
2014.
What sort of results, outcomes have you guys seen that you're measuring over that time?
We use tasks to show what we've looked at and what we've closed out. And we've closed out over 2,100 tasks in that, which is a considerable amount of stuff. We've saved over $2.5 million, proven dollars, not avoidable costs, proven savings through our energy bill. So that's how we're gauging our success.
Awesome. And we have a few more friends here. Before we bring them on, can you talk about the deployment and sort of integrating the software into the operations?
Sure. We started out as a lot of people do. We thought we could self-manage. Nobody's better than us and doing maintenance stuff. So we wanted to bring everything in-house. We were going to have it on-prem. We were going to make our own vaults. We were going to make our own graphics. We were going to do all this stuff. Since we were a partner with Microsoft, we went with an Iconics platform, which does exactly what it's supposed to do, but it just didn't fit us. After that first year, we were spending way too much time building our own graphics, doing all that stuff, that we realized, why not have this team of people from all around the world developing the program for us? So we went out for an RFP, and that's how we got hooked up with Clockworks. Once they got on board, that's when things really, really started to ramp up, in my opinion, as far as seeing savings and different things like that. We decided to do a pilot of 10 buildings, a mixture, not necessarily who we're going to save the most money on, but we wanted classrooms. We wanted energy buildings, so like research labs, some of the athletic facilities, amounts of equipment, high and low. We wanted to try all those so we can, base what we would move forward with if this was successful. So it was very successful. So we went with a round two. I believe we did 23 more buildings in round two. We did a lot better selection then. It wasn't so much we're trying to discover. We already figured that out during that first pilot. So I think the first pilot, they onboarded us in about 3 months. The second one, I think, took a little bit longer, more like 8 months to get the second one onboarded, which is understandable. There's much more work to do there. I will say, in their defense, I was telling them to slow down. How am I going to get all these buildings checked out and everything else? So I was saying, you guys got to slow down. You got to slow down, which I'll never say again. But it was amazing how quickly they onboarded it. Where we just spent a year doing one building, they brought on 43 buildings in less than 11 months. Once we had all that going, we decided to form this our group. Hey, we got about 3,500 faults we could be acting on. So we got plenty of things to do every day.
Yeah, I love that story because it shows the journey you went on. One software provider, it didn't quite work for us, thought we could do a lot more in-house than we actually could. So we pivoted, went out for RFP, did another pilot, and then rolled out in a large way, and then built the team, developed the processes. So we're going to focus on those two last things. We're not going to go into why you selected a certain software today. We're going to talk about the team and the processes. And the idea here is to dive into those two things because it really, I think that's where we're at sort of as an industry, is that I think a lot of people have validated that this tool is needed, especially when you have more buildings than your operations folks can get a grasp on, right? You have a lot of deferred maintenance. You have stuff breaking all the time. You have a lot of hot and cold calls. People have realized that FDD is an important tool, but I don't think a lot of people have figured out how to integrate it into their team and make it work on a day-to-day basis. So now let's bring in Brad and Katie. They've been ghosting in the background here, and they're going to bring them onto the front stage. So Brad, let's start with you. Can you do a little introduction to yourself and talk about what your role is on the team?
Yeah, I'm Brad Dameron. Been at the university now for almost 4 years. And I was kind of brought in to, I think, try to take the FDD to the next level and really branch out. Initially, when they got the software, you get a lot of the low-hanging fruit. You get these big projects and big savings, and those are pretty easy to pick and choose from. And, it's gets people excited. But then after you've had it for a while, okay, the savings kind of goes down and down if you're doing your job. So, okay, now what do we do with it? well, we need to refocus and, okay, how do we use this as a maintenance software, and how do we be more proactive rather than just, okay, it's finding these things. Okay, what are we going to find before it becomes a big problem? That's kind of more of the push, and that's where more of my role, I guess, is, trying to be that more proactive person. We're looking for these things that we can catch before they become a big problem, and then actually getting it out to the field, getting it out to as many people as possible so we can get as much done using the software as we can, and just trying to be more efficient.
Cool. And we're going to come back to a lot of those process-oriented things that you're sort of delegating tasks out and that kind of thing. Katie, can you jump in and introduce yourself and talk about your role in the team?
I'm Katie Rossman. I was on the team with Tom that helped to implement the FDD program at the University of Iowa. I sort of had a dual hat of energy engineer when I first started the program, and then I moved into more of a leadership role as the manager of building analytics and commissioning. But I still really wore that energy hat as part of a member of the ARG group. I have now since transitioned from my position at the University of Iowa, and I work actually on the Clockworks Analytics side. I've been there for about 2 years. I am the director of the Technical Operations Center, which I lead up the team of service engineers that help clients like the University of Iowa with process improvement, helping them use the tool, find value out of the tool. So I basically do the same thing that I did at the University of Iowa, but for a broader audience at Clockworks.
Yeah, so you can weigh in on how you guys did it at Iowa when you were there. You can also weigh in on best practices that you've seen since you've left in terms of people integrating the technology into operations.
Absolutely.
Can you guys, starting with Scott, talk about the other people on the team and what their other roles are? All of these people aren't here, so we won't drag their name through the mud at all, but talk about what they're doing on the team.
So Scott Sellner is our controls technician, controls lead as part of our R group. He's really involved with the programming side of stuff. He'll definitely go out in the field and help with that stuff. But with this platform, you do find a lot of programming changes that you need to have. So he's responsible for either making himself or getting it to the other people in the controls group that we have here at Iowa. We're very, very lucky at Iowa to have a controls group. I think it's up to 8 people now that do nothing but programming and BAS work.
Awesome. And who else would you guys consider to be on the core team?
An IT professional for sure. Ours happens to be a guy named Sarn, but without the IT professional, I don't think we would be where we're at for sure.
Totally. And can you just talk about a little bit in more detail of what his role is on the team?
Yeah. So during our RFP, he was very integral. He was telling us what was real, what wasn't, what these vendors were telling us. He was telling us who we could integrate and who we couldn't integrate with. It wasn't us making a decision and going to IT and telling them to make it work. He was really, really important to make sure, as part of the selection committee, on what we were going to choose. So then once that happens, he runs all the background stuff, make sure the connections are there, the firewall's up, and doing all that good stuff. He tells us when we need to change literally some of our programming stuff he's helped out with. So, but definitely in the beginning, that role gets really diminished after you get rolling. But in the beginning, you have to have it or you're going to be wasting a bunch of time because you're going to pick something, you're going to take it back to your IT professional and they're going to say, we can't make that work. So now we got to go to number 2. Had we had him on the first pilot more involved, I think we would have probably made some different decisions. So that we definitely made in the second pilot.
Got it. Okay. All right. Who else is on the team?
I would say all of our frontline techs and our managers. We're really trying to integrate them much more than we had in the past. So I would say that they're definitely part of our team.
Got it. So it's not just this external team that's sort of throwing stuff at the frontline technicians. It's
right.
These people are part of the team and we're sort of trying to integrate it into their daily workflow. Yeah. That's awesome. Yeah. So I understand with this team, when you guys were building it, Katie, there was something that you were arguing maybe with Tom about that.
Friendly
maybe
banter.
In retrospect.
Friendly banter.
Yeah, friendly banter. There you go. There was no arguing.
In retrospect, it looks like you're on Tom's side now. Can you talk about that sort of friendly banter argument.
Yes, so to be clear, Tom and I are very much peers. As we were sort of given our charge to go figure out what this FDD thing is, and we had talked to some other folks who had been using the tool. It had been sort of sold to us as an energy tool. And so, my thinking was instantly like, this is an energy management functionality. This is something that energy managers take. We look for problems and we communicate it like in a more classic energy conservation measure, energy project spreadsheet. You know what I mean? And track it outside of your maintenance organization. And Tom kept pushing me like, no, Katie, this needs to be something that maintenance does. Maintenance needs to have a really integral role in this tool. And it was very much a difficult mindset for me to grasp that it can't be the more kind of rigid project implementation that needed to be part of our day-to-day lives and how we do maintenance. And so I will never live it down, but Tom was 100% right and I was wrong. That I really believe that was integral to our success is the integration to our CMMS, the use of work orders to push action instead of relying on some external tool that our maintenance people don't speak tasks, they speak work orders. And so the more it looks like their day-to-day hot and cold call, the better it is, right? So if we can make that push of that FDD resolution look like a work order, then it's much easier for the organization to adopt it. And also they get much better adoption when it's someone like Brad who's sending the work order out, who can go and get his hands dirty and fix the problem. And, if they need help, he can go help them. Whereas if it had been me sitting at my desk looking at energy numbers in a spreadsheet, I don't think there would have been that same buy-in. So I think that was really important that we had well-respected, really good technicians that were already fixing broken stuff anyway, just come and fix it in a different way.
I love this insight because, in a lot of organizations, an energy engineer could be an external consultant. It could be someone in a different department. It could be someone on the portfolio level that's kind of outside of the group. They're not boots on the ground. They're not there every day fixing stuff, right? So the fact that you guys decided, well, Tom overruled you there and decided.
No. It was very much. It was very
I finally
much.
had her come around to the truth. I don't know.
I'm just messing with you guys.
But
So
I will say that Katie brought up the CMMS. We treat these like any other work order. They do not get special treatment when it goes out to the front line. And I should have said that earlier. So that also helps with the implementation too, because we have what our customer timeframe expectations of when tickets are going to be finished. So we are able to use that metric to see how successful we were being with these frontline folks.
And I do think this actually really speaks to the same decision we came to with what platform we used was what our organization was good at. I've seen this energy management run FDD programs work well at other organizations, but with the resources we had at Iowa, the funding sources we had at Iowa, the levers we had to pull to execute work, it wasn't going to work if it was coming through as an energy project, just based on history at the university and the resources that we had at the time. It was going to be a much more successful program if it was run through our maintenance organization. And we had such good buy-in from leadership with Tom that that helped a lot too, right? That we were both at the table together as peers, kind of coming up with what this program looked like. I think that was also really helpful in our success.
Yeah.
And we do obviously still like each other, so it must have worked.
Yeah.
Our kids go to the same school, so we kind of
have to. Yeah. Okay, so before we move on to the actual process, which is one of the things I'm most excited about here to talk about the big ass flow chart. Tom, I want to see if you have any advice for people that are trying to select who should I make this analytics super user on my team? Should it be the top technicians? I think a lot of people say, no, I want my top technicians out there still doing what they were doing before. They're our most productive people. I think they say, maybe I'll, pluck this newcomer and have them be the person. Why did you guys select the top technicians?
Because they're still doing work, right? I mean, this is not like we, drug the work system down in the shop once they left, because they were still doing stuff in that shop, but it may just not be all day, right? And really, as good stewards for the university, we need to put the best people in every best situation that fits that situation the best. We're distributed. We're not a central maintenance group. We have 5 shops on campus. It's great to have this group just be that single point of truth, right? Like if I have a problem, I'm going to call them. This is what I'm looking for. This, they're watching my back with this program because they might be able to get something fixed beforehand. Getting projects done that never would have got done before, right? Because now we have the data and the proof to say, hey, this is, we need to do this. We could be saving, $25,000 a year just by, getting this air handler out of here. Selfishly, I knew I needed some people that were well respected on campus, known to be teachers of others and known to get the job done, helped out.
And they were doing FDD on their own anyway, right? So they were already manually looking at the BAS in the morning to try to find problems. So it's just replacing the tool with something that's easier for them.
Absolutely. All right, let's talk about the big ass flowchart. I first saw this last fall when I was with you all in Boston, which was super fun. I was very impressed by the detail in which you're laying out this like process flow. Brad, do you want to take us through, describe what this is? We'll put a link to it in the show notes. We'll share it, like this actual flow chart, with everyone that's listening to this. You can find it on our website. But Brad, can you talk us through it?
Yeah. This is actually one of the first things I helped with when I started here. Is we said, we really need a flow chart so we can explain, well, both to ourselves and to everyone else, what does it look like when a fault comes in? What are our duties? And yeah, the number one thing is, is it a true analytic? People think, well, yeah, it just spits it out to us and we just automatically put out a work order or something. First is evaluate, is what this is telling me true? Is it a sensor error? Is it is it a mechanical thing, or does this not make sense at all? And, not every fault is a real issue. And so gathering all that information with the software, we get all the trends and we can see all the sensors that are involved, how they decided that this was an issue. And you still got to put a human brain to it at some point and say, okay, does this make sense? If it doesn't make sense to us, we have regular meetings with the software provider that we can take issues to. It's like, this doesn't make sense to us. We don't think this is a true fault. Or can we adjust this fault? This is too tight a tolerance. We've had to do that many times. Brian and I are the first line of defense. So we're looking at these faults day in and day out. We both have over 25 years experience in HVAC and controls. So between the two of us, 50 years experience, we can kind of tell, okay, I got a pretty good idea what this is. Then I can say, I can either send it to the group area maintenance guys and say, well, I want you to look at this. I'm pretty sure this is the issue. And if it's not that, then go ahead and get back to me. That's the ideal situation. So, what, this is kind of a bigger scale thing, then we'll go out ourselves and put our eyes on it, put meters to it and verify, okay, this is a issue. Okay, we know exactly now what trade we need to get in there. Okay, we need an electrician or we need a pipe fitter to change out a valve. This valve is failed. Or is it an electrical issue? Or, what, this is even bigger scale. We need to create a project. Because we have around 3,500 faults per day that we're trying to prioritize. And the software does try and bring up the top scoring faults. So this is where we show the most money it's costing you. Or we can sort by comfort issues. This is what's causing the biggest comfort issues that you might want to address. Or we can sort by maintenance issues. Okay, this is a mechanical failure, the top mechanical failures that we've, come across. And we kind of have different focuses on different days or maybe even weeks or months. That's where I think it takes somebody that has that experience and can decipher what direction you're going with that. Also, we figured out that the software actually provides a link to all the trends and all the data that it used to find that fault. We attach that right to the work order. So the tech out in the field can just click on it now and go right to the fault. And they've really been loving that too. And, you get a lot more buy-in that way. It's something we've learned that goes a long way.
Yeah, I'm sure. Thanks for taking us through that. Katie, I'm wondering, so one of the things I think is interesting here is we have the integration of two systems, right? We have FDD and we have a work order system or a CMMS. Those two pieces of software are integrated with each other, but it doesn't seem like that integration is automatic, really. It's not like every fault is coming in and creating a work order. So Katie or Brad, however you guys want to take this, but can you talk about why it's only some of them? And maybe it's obvious, but I think it's not obvious for the tech folks that are just like integrate everything together, right? Why is that a manual decision of what gets brought in from the FDD to the work order system?
I think the main reason that it is a manual process is because of what Brad was speaking about that kind of pre-vetting of the diagnostic results. Your output is only going to be as good as the data it's consuming. So sometimes you'll have issues with sensors that are causing problems. You'll have issues with the way that diagnostic might be configured is based upon a sequence of operations that no longer is used anymore, or it's based upon assumptions that Iowa no longer makes anymore, right? So having the human input of generating that work order gives it just kind of that first vet before you send it out to the field to go look at it. You're doing that kind of initial triage to say, okay, here's where the issue is. The other reason that it's nice is because a lot of times what you're looking at potentially are a list of symptoms and then a problem, right? And being able to see all of those symptoms in tandem with the problem allows you to kind of say, okay, the root cause of this issue is this one valve. So it also allows you to kind of send that work order out and say, pay attention to this valve. There's all of these other symptoms that are happening, but the thing that you need to fix is the valve. So it does kind of allow you to like, when you're actually taking action, give directed information to the field. Right. And when you're getting that diagnostic result, so kind of to Brad's point, you're seeing all of those symptoms and the problem identified for you, right? And you're seeing like a list of recommended corrected actions. When you create that work order, it's going to show all of those things together, right? Because they're all interrelated. And so if that were to automatically send out, it might give confusing instructions to the technician too. So Brad's able to say, okay, I see all of this information at once. This is the problem, and kind of narrow down on that.
Amazing. So I want to kind of repeat sort of the big ass flow chart sort of back to you guys. There's one loop of an ongoing meeting and tasks around just making sure the software is doing what it's supposed to be doing, is keeping updated, is sort of tailored to how you guys want to see it. And then there's another loop around tasks and validating tasks, tracking tasks, getting them implemented. So that's an ongoing meeting, repetitive meeting as well. And then there's this triage piece that Brad and Brian, our two sort of super users, are saying, I'm going to assign this to the right trade. I'm going to track this. I'm going to support them in the implementation. And then I'm going to see if it's resolved after the fact. And so it's like kind of like three different loops going on. That's really cool. That's really awesome. So let's do a little storytelling. Is there one project that comes to mind, Tom, that you would tell to another university at a conference saying, let me tell you this cool story about what we did in our FDD program?
So this is one when with the original software and when we first started doing this, right? So this was kind of my aha moment. It does work. So we just built a new huge wet lab building, a biomedical research building, 6 stories of wet labs, and then another 40 feet or 4 stories in the ground with supporting equipment and OAR space and different things like that. So this was the building we picked to do first. I had to pick the most complicated building we had, newest building we had on campus, which I think is great because we learned a lot by doing that, as opposed to if we just had a couple quick wins, we would have never made the decisions we made. So the guys found out that they were not getting the discharge air temperature that they thought they should out of a bunch of VAVs in the same room, right? So they go out there, they start setting up their ladders, and the department head comes over and goes, "What are you guys doing in here?" And they're like, "Well, we run this software over here over our building automation system that's telling us that you're not getting the heat that you need to get out of these coils." And they're like, "Well, it's fine to us, but if you want to go ahead and check it out." So Jeff and Bob get up there, and we had to have the pipes re-insulated as part of one of our punch list checks for this building. Insulator came through, insulated, and shut all the hand supply and return hand valves off to all the VAVs. So we had no hot water going to those VAVs. So Jeff and Bob went up there, opened the ball up, and it was like they almost applauded them as they left. They're like, this is the best it's felt since we've been here. And they're like, well, why didn't you call us? And they said, well, it's a new building. We just assumed this is what we were going to get.
I just thought it was supposed to be like this.
Yeah. So for me, it was a win on so many different levels. We had a win with the customer. We had a win with proving that the software works. And we really got into this hoping we could do predictive maintenance, right? With some of the AI stuff that's coming out and different things. So that to me was about as predictive as you can get, right? We solved the problem before it became a problem. And it was a problem, but the customer didn't know they had a problem.
Yeah. So the output on the valve was, I need heat.
Right.
But then you had a manual valve that was closed down, not letting it get any water.
Correct.
And I guess how long would it take to find something like that? You wouldn't find it until it's the coldest day of the year or something. And yeah.
Till they complained, to be honest.
Yeah. Yes. So with the last 10 minutes we have here, I would love to talk about some lessons learned here. And we've kind of gone through these together before we hit record here. So I'm going to sort of feed them to you guys. And then I want you guys to sort of talk about those. So the first one, and I think this is my near and dear to my heart, because it sounds like there was some pushback from technicians that were saying like, all this analysis that this software is doing, that's my stuff. That's my magic. That's my career that you're sort of automating away. How have you guys sort of managed that piece of this? Because obviously on one hand, we're using technology to get more out of less people. But on the other hand, if someone really likes trying to go find problems and finding the needle in the haystack manually, you might upset them.
It is still an issue for some people, and it's showing them that, most of the things that the software finds is not things that you're going to find just stumbling across it. If you're sitting there looking at your BAS all day, every day, yeah, you're going to catch it, but you have work to do. And it's convincing them that we're not there looking over your shoulder. We're not trying to make you look bad. We're there to help. This software is helping you do your job better. And it's, finding the needle in the haystack. It's not something you're probably going to find. Those things are reactive. We're not looking for the reactive stuff. We're trying to find it before it becomes a big deal. And it's educational. It's just getting out there, talking to the people, showing them what it's all about, and showing them that we're not here to make you look bad. It's not going to make you look bad. It's just another tool in the toolbox. And that's what we really try to emphasize. This is a tool that we're using, just like all your other tools.
They take pride in when we have a $25,000 energy save, they're involved. They're helping with that fix. Having those kind of winning situations really helps. It also helps. We spur projects that improve their space, right? That we weren't getting money for before. So I think through several projects that we've done through our IMU Blitz and different things, and we made the building that they take care of so much better, they see the benefit of this, right? So it's kind of going out.
We talk about, peeling the onion. Well, this fault may start pretty small, and the energy savings on this fault may only be a few dollars. But by the time you unpack that and you keep peeling the onion back and peeling it back and peeling it back, this thing just grows and grows and grows. And it's like, you know what? This is actually a big deal. We can submit this as an energy project. And I mean, we've had some big success stories.
Totally. Okay. The next one we had was evaluating where your strengths are. It sounds like you guys talked about this a little earlier. There was a little bit of like biting off more than you could chew at the beginning. So how have you figured out as an organization, there's a lot to do here, IT, software, programming, database, obviously all of the implementation we've been talking about. There's a ton to do in this process. How have you decided what to take on, what to outsource, et cetera?
So when we initially did our pilot and we were looking to self-perform everything, I think like one of the biggest data points that proves that there's a something to be said for letting someone else do something that's better at it, and that's the onboarding time. So when we onboarded that one building and our pilot and we did all of the self-performing, it came down to, I think it took us 6 months to just get points communicating, just the learning curve of figuring out the integration and how to point map everything in, and then writing faults and the management of those faults, right? The change management of, oh, this air handler operates this way, this one operates slightly different, and like trying to track all of those changes. We just didn't have the tools, the resources, the people to manage all of that. It was basically just going through me to make any adjustments to the analytic results. And so I think that alone was sort of like, we probably shouldn't do this in a vacuum, right? There's a beauty to being able to crowdsource some of this stuff that people have already. The case I really made, and I was like, I think we need to pivot here, was there are people all over the United States writing the same economizer fault 10 different ways.
Right.
It's like, why
Right.
am I the 11th, So like, it feels like there was some like scalability that could happen through kind of a crowdsource model. So that's one of the main things right away that we were like, this is not something that we can take on as an organization. It's not our strength. We have always been very particular that the troubleshooting and determination that something is actionable, we have owned, and that's remained. That's been that like our bread and butter. And that was really from the very beginning, was we want to own deciding what we do in our organization as far as what tasks and work orders we say are actionable, right? Because we understand our business model, we understand our priorities and what's important to us. So that was something we always really wanted to own.
And this is a thing that, you guys have seen a couple different FDD vendors. I've seen like all of them. And it's important for people that are listening to this that are just starting down this journey. Not all FDD products can do what Katie just said in terms of crowdsourcing and sharing these concepts across customers, across buildings, across geographies, across units like in Europe or Asia or whatever. And so one of the things we're trying to do with our partner program is really set standards for, if you're selecting FDD, it needs to be able to do this. And I think that's one of the things that's really important, is being able to use what other people have already written. The other 10 people that are writing economizer rules, the product should be able to make it so that we're not recreating the wheel every time. The third lessons learned you guys gave was having leadership buy-in from the beginning. Could you guys just tell that story of how this kind of started with Don and his sort of vision that sort of helped you guys get this off the ground?
Don Guckert, who was the AVP at the time at Iowa, came to Tom and I and said, I've read this article. This Doug Litweiler also was pretty instrumental in this. And there was an article that had been written about Microsoft's implementation of FDD. It probably was from like 2008, because that's when this journey really started. So I think even pre Tom and I, Iowa had made a trip out to Microsoft, had visited their campus, had seen their FDD program in life, and then came back and kind of told Tom and I to make it work, right? So then we also took a trip out there, and we talked to the people that were making their FDD program work, so we could kind of ask some questions about it as we were implementing our pilot. But from the very beginning, Don was a very good champion for our program. And one of the biggest lessons that he taught to like very nervous people about something going wrong is to not be afraid of failure, right? So keep going, right? And take some of those risks. And if it fails, we can always change course. And that was really important guidance for us as we were looking for more like, why are we doing this? Are we wasting time? And he just kept pushing us to just test the limits and the boundaries, see what could work. And when we made this decision, we went out for RFP, and the decision was sort of like, this vendor we're picking is not the one that we spent all this time and resources on. Is that a negative here? And it was just sort of like, that was a year of learning, and we need to pivot if it's the better option for us going forward. And it made that choice a lot easier for us to make that switch, because so much time had been invested in that initial pilot.
And that went all the way up through the president's office. He did a great job. He sold it to them too. But I ran into him in the hallway about 6 months after he started. He's asking me how it's going, and I was listing off stuff that wasn't working. And he goes, I want you to stop right now. From now on, I only want to hear what's working. I don't want to hear what's not working. It's your job to figure out why it isn't working, not mine. So I only want to hear the good things, so that was one thing. It was like, he was basically saying to me, I don't care if you screw up, Tom. I'm never going to know about it. And even if I do, I know it's part of the process, 10,000 tries to get a light bulb. That helped me out tremendously.
Yeah. So somebody that understands that this is a process that we're learning here, we're adopting something new. There's a lot of change management involved and can kind of roll with the punches a little bit. That's awesome. So I want to thank you guys so much. This has been super insightful. I think a lot of people will learn a lot. I think that original Microsoft FDD article was one of the reasons that I kind of went down the path that I went on. It's an inspiration still, because think about all the people that have gone down the path since they read that. I'm hoping that when people listen to this, they can kind of have a similar light bulb come on. So before we close this out, I want to ask each of you anything that we've missed that you want to quickly say before we close off.
Just having the right team is a big deal. You got to have the right players. We're successful because we got lucky and picked the right players. And, we're okay with failure. You're going to fail because you can't, all those lessons were learning lessons for us, right? We wouldn't be where we're at without that first program. We knew what we wanted after that. We knew what we needed.
Yeah, totally. Katie, Brad, any closing insights?
I will actually echo this team strength. I think was also really important to our success. I loved this program. I could talk about it all day long until I'm blue in the face. We're not just advertising for University of Iowa. It truly was a real joy to work with this team. And I think the thing that I liked the most about it was that it was truly results driven, right? You can't hide behind fake numbers because people will notice when your bills don't go down or when work orders don't get closed or when your numbers never move, right? There are results that you can tie to your success. And so it was a really meaningful part of my career is being able to work on a team to implement a program that has lasted so long at a big institution.
Awesome. How about you, Brad?
Yeah, I mean, I would echo, having that team of people that are results driven. I think because it's very easy to see your results here. And that's something that I'm driven by. I want to see results from my work, and you get instant feedback. The only other thing I would add is, the educational aspect. From the top to the bottom, that's one of the hurdles. I mean, it's just educating people from the top to the bottom. This is a tool, and this is how it gets used, and these are the benefits. And it's constant. We're how many years in, and we're still, educating people, and it's just going to take time and education. And that was the only other thing I wanted to add.
All right. Thanks so much for coming to share your story here. This is a great story, and I think all people are going to get a lot out of it. So thank you so much.
Okay, friends, as we're trying these new formats, please let us know what you think. In your podcast player right now or on the episode page on our website, there's a link to a survey for this specific episode. We'd love to hear from you, and we want to hear your feedback. Also, don't forget to sign up for the Nexus newsletter or invite your coworkers and friends with the link below. Catch you next time.